Welcome back, grade 8. In this video, we are going to learn how we can multiply exponents. This topic will be divided into two different videos. This is Product of Powers, Part 1, and corresponds to Section 8.2 from the textbook. Let's take a look at our first example. How can we simplify? So how can we simplify 4 to the power of 5 times 4 to the power of 3? Well, what does 4 to the power of 5 mean? 4 to the power of 5 means that I'm going to multiply 4 by itself 5 times. So 4 times 4 times 4 times 4 times 4. All of this is 4 to the power of 5. Now I need to multiply it with 4 to the power of 3. So that means I've got times 4 times 4 times 4. And I have 3 of those. So this is 4 to the power of 3. So we want to simplify this such that we're writing less. So we can count up the number of 4s that we have here. We've got 1, 2, 3, 4, 5, 6, 7, 8. So if we want to simplify 4 to the power of 5 times 4 to the power of 3, well, that's just going to give us 4 to the power of 8. Okay? So let's look at example 2. Example 2 is 7 squared times 7 to the power of 4. So again, 7 squared means 7 times 7. And 7 to the power of 4 means I'm going to multiply that by 7 times 7 times 7 times 7. So again, notice that this here is 7 to the power of 2. And here we've got 7 to the power of 4. So if we want to simplify that, we're just going to need to count up the number of 7s that we have. So here we've got 1, 2, 3, 4, 5, 6. So this is going to give us 7 to the power of 6. So let's look at these 3 examples. Hopefully you're starting to notice some sort of pattern. So if we have 2 to the power of 6 times 2 to the power of 4, that's just going to be 2 to the power of 10. And 2 to the power of 4 times 2 to the power of 2 is 2 to the power of 6. And 3 to the power of 5 times 3 to the power of 7 is going to be 3 to the power of 12. There is a general rule we can use when we need to multiply two exponents. So our general rule is that when we have a to the power of m times a to the power of n, it's going to be a and to the exponent of m plus n. So if we take a look again at that first example, it was 2 to the power of 6 times 2 to the power of 4. Well, the exponents were 6 and 4, so we can just add them. 6 plus 4 made 10. The most important thing to know about this rule is that this rule only works when the bases are the same. So again, the bases are these numbers here. So I'm going to highlight all of the different bases in yellow. So this is a base, this is a base. Notice that they're both 2s. So they're both the same, so that's why we can add the two exponents together. This has a base of 3, this has a base of 3, so we can add those two exponents together. So for example, if I have 3 to the power of 2 multiplied by 2 to the power of 3, I can't do 3 times 2 is 6 and then 2 plus 3 makes 5. That won't work. The most important thing that we need to note is that the bases need or must need to be the same. This is really important. So let's take a look at another example. We have 4 to the power of 3 in parentheses, all raised to the power of 4. So in order to simplify this, it's best to understand what this means if we expand this out. So we have 4 to the power of 3. 4 to the power of 3 means we're doing 4 times 4 times 4. But if we look at this 4 on the outside, what does that mean? It means we're multiplying 4 to the power of 3 by itself 4 other times. So we have one set of these, a second set, we have our third set of it, and we have our fourth set of that. So we now have 4 to the power of 3 times 4 to the power of 3 times another 4 to the power of 3 times another 4 to the power of 3. And if I count up all of these 4s like we did before, I should get 4 to the power of 12. So let's apply that same theory to the second example. We have 7 to the power of 2, all raised to the power of 3. So again, let's think about what we have. 7 squared. 7 squared means 7 times 7. And this 3 on the outside means we're multiplying 7 squared by itself 3 additional times. So we're going to need, this is one other time, we have this other time here. So now I have 1, 2, 3 sets of that, and they're all being multiplied together. So we can count. How many 7s do we have? We have 1, 2, 3, 4, 5, 6. So we've got 6 of these, so 7 to the power of 6. So these are examples of the power to a power law. So I'm hoping you can kind of see the pattern again like we did before. If I have this example, 2 to the power of 6, all raised to the power of 2, well that's going to be 2 to the power of 12. And if I have 3 to the power of 5 raised to the power of 3, that's going to be 3 to the power of 15. So just like before, we have this general rule, and our general rule for this one is if we have a to the power of m, all of this raised to another exponent n, we simply just need to do a and raise to the power of mn. Now remember, when we have two variables next to each other but we don't have any symbols, it's like saying a to the power of m multiplied by n. So if we notice here, we had 6 and we had 2. How did I get 12? Well, I did 6 times 2 to make our 12. And then in this case, we had 5 and 3. How did we get 15? Well, we did 5 times 3 made 15. Here are 6 questions that you can try on your own and apply what you just learned from the video for these 6 problems. Now I want you to take a special look at number 2. So number 2 here, we've got negative 1/2 raised to the power of 3 multiplied by negative 1/2 raised to the power of 6. I don't want you to be discouraged that there are fractions. So this is a base of negative 1/2. Both of them have the same base, so you can still apply that product rule to solve this one. So take a look at these 6, complete these ones for next class.